Okay. Can you guys see my screen okay? Just want to make sure you guys are able to see the screen before I get going. Awesome. Thank you, Brendan. Okay. So we are going to begin our discussion today talking about angles of rotation in standard position. So first I want to define what standard position is. Standard position is when the initial side of an angle is on the positive x-axis. And all of the angles that we are going to draw and talk about today will be in standard position. Okay, so when we talk about angles, if we measure an angle in the counterclockwise direction, so starting on the positive x-axis and then rotating in a counterclockwise direction, we call that a positive angle. And if we start on the positive x-axis, so standard position, and we rotate in a clockwise direction until we get to our terminal side, that we describe as a negative angle. So again, positive angles are when you measure an angle in a counterclockwise direction from the initial side to the terminal side. The initial side is where our angle begins. That's going to be on the positive x-axis. And the terminal side is where our angle ends. So positive angles, when you measure an angle in a counterclockwise direction from the initial side, the positive x-axis, to the terminal side. Negative angles, pretty much the exact same definition, except we're measuring clockwise. All right, and we are going to sketch just a couple of examples here so that we have some good reference points for what positive and negative angles are going to look like. So we're going to do 2 for positive and 2 for negative. So go ahead and put 2 coordinate planes where you are talking about positive angles and 2 coordinate planes where you are talking about negative angles. All right. So for my positive angles, our initial side, positive x-axis. There's the initial side of my angle. I'm going to go in a counterclockwise direction until I reach the terminal side. That would be an example of a positive angle. When we talk about angles, I don't have to only go around once. Angles can extend beyond one full rotation. So it's possible that I have a positive angle that is bigger than 360 degrees. If I start on my initial side and I rotate in a counterclockwise direction until I get to, say, here, that would also be a positive angle. One full rotation and then a little bit beyond. Any angle that I can describe with a positive angle, measuring it counterclockwise, I could measure that exact same angle in a clockwise direction, and then it would become a negative angle, like this over here. Same exact initial side, same exact terminal side as the first angle that I drew on the positives, but because I'm measuring it in a clockwise direction, this would be a negative angle. And I could have the same thing happen where I do that and I go beyond one full rotation. So I could go all the way around and then most of the way around again. And I could get a very, very large magnitude-wise negative angle. Almost looks like a snail there. We're going to practice sketching some positive and negative angles. So before I actually bring up those examples, does anybody have any questions for me? Does anybody have any questions at all about positive or negative angles? Okay. I'm going to put up 3 examples and we are going to sketch these. All right. We're going to sketch a 60-degree angle, a 250-degree angle, and a negative 100-degree angle. So I'm going to put my coordinate plane on here. My initial side, my positive x-axis, where I would start from, is going to be 0 degrees. Since we're talking about a positive angle, we're moving in a counterclockwise direction. So how many degrees of rotation would it take to get up there to the top of the positive y-axis? Once I have rotated from my initial side up to there, how many degrees have we gone through? What would be up at the top? "90 degrees. Thank you, Brendan. Right, what about if I were to rotate all the way over here to the negative x-axis? How many degrees of rotation would that be? Thank you, dear. 180 degrees. What about if I kept going down to the negative y-axis? How many degrees of rotation would that be? 270. Awesome. And what about if I came all the way back around to where I had started? What if my terminal side lands right on top of my initial side? Thank you. 360 degrees. Okay. So I want to get that labeled there first so that I have some points of reference. Since we're positive angle, we said we're going to be going in a counterclockwise direction. What quadrant? 1, 2, 3, or 4 would a 60-degree angle be in? It's going to be in quad 1. Yes. 60-degree angle is going to be right about here. Here's my initial side. And so this would be my 60-degree angle. For B, are we going to be going clockwise or counterclockwise? Clockwise or counterclockwise for B? Counterclockwise again. How do we know? How do we know whether it's clockwise or counterclockwise? Positive angle, that's absolutely correct. So I'm going to leave it labeled the exact same way. And what quadrant, 1, 2, 3, or 4, would 250 degrees be in? Quadrant 3, absolutely. 250 degrees is going to be right about here. Initial side on the positive x-axis. And so here's my 250-degree angle. Last one, part C. Are we going to be going clockwise or counterclockwise on part C? Clockwise this time. And how do we know again? Negative angle. Absolutely correct. I'm going to need to relabel this since I'm going in a clockwise direction. I'm going to need to relabel all of my angles as I move around. So if I start off on my initial side, my positive x-axis at 0 degrees, when I go clockwise, I'm going to reach the negative x or the negative y-axis first. How many degrees of rotation will get me down to the negative y-axis? Close. 90 degrees, because I'm starting here and I'm just going to go like this in a clockwise direction. Now, since I'm going clockwise, I wouldn't label that as 90. I would need to label that as what? Negative 90. There we go. So negative 90 degrees if I go from my initial side to the negative y-axis. How many degrees of rotation to get over here to the negative x-axis? Negative 180, absolutely correct. What about to get up to the positive y-axis? How many degrees of rotation now? Absolutely correct, negative 270. And if I make a full rotation and my terminal side ends right on top of my initial side, how many degrees of rotation? Negative 360, yes. Okay, so now that we have this labeled with our reference points, what quadrant will negative 100 degrees be in? In the third quadrant, yes. Here's my initial side. Negative 100 degrees is going to be right about there. Beautiful, beautiful, beautiful. All right. There is another way to measure angles. We've been talking about degrees. Yesterday, we talked about degrees, minutes, and seconds. We talked about decimal degrees. We've just labeled these XY axis with degree markings, but there is another way to measure angles, and it gets used a lot in trigonometry. That other way to measure angles is called a radian. To figure out how many radians something is, I'm going to take the arc length, so along the outside of the circle, and I'm going to divide that by the length of the radius. I want to write down a formal definition of a radian, and then I'm going to show you an animation that will hopefully make it a little bit clearer exactly what a radian is. So 1 radian is equal to the measure of the central angle of a circle subtended by an arc equal in length to the radius of the circle. I realize that that's a fairly long definition. And it's got some words in there that we're not 100% about yet. Take a moment to get that copied down. And then I want to show you an animation that will hopefully help clear it up at least a little bit. All right, I'm going to come back to this screen. So if you don't have it all the way copied down yet, that's okay. I'll come back here. But I want to pull up this animation for us to watch. And I will make sure that you guys have access to this as well. All right, so there's our radius, and we're going to use that to draw a circle. Then we use the radius almost as a measuring tool, and you wrap it along the outside of the circle. That arc right there gets used as the terminal side, and then we've got the initial side. That is 1 radian. Then I can use that to measure around the top part of the circle. Notice I can fit 3 full radians across the top, and then there's a little bit more there. That's the 0.14, 3 full radian measures around the top. And then that little bit more, that's what pi is. And that's where pi comes from. It's going to play again here. So there's my circle with my radius. We use the radius as a measuring tool then along the outside of the circle. And that's what forms our central angle. That is 1 radian. And then doubling that would give me 2 radians. Again, notice I can fit 3 full radians and then just a little bit more. That's pi. So all along the top half of the circle is pi radians. So then when I go along the bottom of the circle, that's the same size as the top of the circle. And so that would be 2 pi radians to go all the way around the circle there. I'm gonna let this play one more time and then we'll go back to the page that has the definition on it. So I've got my measuring tool here. That angle right there is 1 radian. And then 2 radians, 3 radians, and just a little bit more to get to pi, 3.14159. So half a rotation around the circle is pi, so a full rotation would be 2 pi. All right. So back here to this, I'm going to try to kind of recreate or draw pieces of that animation there. Let's see how well I can do. That is not in the right spots at all. Almost. Having difficulties with my circle tool here. There we go. That's close enough. So I've got my circle drawn here, going from the center to the edge. There's my radius r. If I take that length right there and I use it to measure along the outside of my circle, so that this distance is also r. I'm going to call this angle right here alpha. And alpha would be equal to 1 radian. If I measure again that same distance, let me pick a different color here. Let's do purple. Measure that same distance here. So this is also r along the outside of the circle. So now I've gone 1 radius measurement, 2 radius measurements. I'm going to call that angle beta. That would be 2 radians. And if I do that a third time, this angle right here, I'm going to call this one gamma. So gamma would be 3 radians. And notice we have just this little bit extra here. This little bit right here is 0.14159 on and on and on and on. So that if I start on the initial side, this is 0 radians here. If I go halfway around the circle from that animation before, how many radians have I traveled if I'm going counterclockwise from the initial side, the positive x-axis, all the way around to the negative x-axis? How many radians of rotation is that? I've got 1, 2, 3 full radians, and then a little bit more. What did the animation say? You bring it back up and we can watch it again if we need to. There we go, absolutely. Pi radians. So over here is pi radians. Just like we practiced labeling around the circle in degrees, Oh, that's okay. It's actually an alt code shortcut. I can show you how to do it at some point, but yeah, for right now, just type in PI. It's honestly faster than the alt code. Just like we practiced a little bit ago when we were drawing in angles, getting our positive and negative x-axis, our positive and negative y-axis labeled in degrees, we're going to practice labeling this in radians. And we're not just doing it here. We're going to do it in a minute because we're going to do some sketching of angles in radians. Okay, so 0 radians is my initial side. If I go halfway around negative x-axis, that's pi radians. How far is it if I complete one full rotation all the way around and my terminal side ends on my initial side? 2 pi, absolutely. So just like before where we had both 0 degrees and 360 degrees labeled here, I'm going to have 0 radians and 2 pi radians labeled here. What would the very top, the positive y-axis be? My initial side is 0 radians. Halfway around the circle is pi radians. What do you think would be up there at the top? 0.5 pi, or we usually write that as pi over 2, half of pi. Pi over 2 radians up there. What about down at the bottom? Negative y-axis. I have 0 radians. I have pi over 2, or 1/2 pi up at the top. Pi radians when I make it halfway around the circle. What would be down at the bottom? How many radians would I have when I get down to the bottom? 1.5. Yes. We usually write these as improper fractions. So I'm going to write it as 3 pi over 2. It just simplifies it rather than writing mixed numbers or decimals. We're going to write these as improper fractions just to make it easier to look at, and it becomes easier to count around our circle. Okay. One other thing that I want you guys to note right here. Radians are really special because radians do not have units. Because we find a radian by taking our arc length and dividing it by our radius, whatever units, inches, centimeters, miles, kilometers, we would be using to measure along the radius and along that arc, because we'd have the same units in our numerator and in our denominator, they're actually going to cancel out. Radians are just a number. They become almost like a ratio, almost like a scale factor, if you want to think of it that way, just because our units have canceled out. So radians do not have units of their own. Okay, just like we did with the degrees, we are going to sketch some examples of angles using radians. And we're going to start by labeling our positive and negative x-axis, our positive and negative y-axis. So I want you guys to look at those labels that I have in black on our circle right here. And I want you to make special note of those. Okay, we're going to do 4 examples. So I need to get 4 coordinate planes sketched here. All right. I have 2 measurements in radians that go over on the positive x-axis. What's going to go over on the positive x-axis as I'm talking about it in radians, both my initial and if I made one full rotation in a counterclockwise direction? What two measurements need to go over there? Close. I'm going to be sketching pi over 4, but first I want to do similar to what we did with our degree markings, where we had them marked as 0 degrees and 90 degrees and 180 and 270 and 360. There we go, 0 and 2 pi. 0 and 2 pi. What's going to go up at the top here? Pi over 2. What's going to go over here on the negative x-axis? Pi, absolutely. And down at the bottom, negative y-axis. 3 pi over 2, yes. Okay, we want to sketch the angle pi over 4. Am I going clockwise or counterclockwise? Clockwise or counterclockwise? Counterclockwise, because it is positive. So I'm starting on my initial side and we're going to be moving this way. What quadrant, 1, 2, 3, or 4, is pi over 4 in? First quadrant, yes. Right here is going to be pi over 4. On B, are we going clockwise or counterclockwise? Clockwise or counterclockwise on B, because it is negative. So we're going to start on our initial side and we're going to be going this way. I'm going to need to relabel my x and y axes then. I have 0 radians here. What do I need down on the bottom since we're going in a clockwise direction?
Pi over 2.
Pi over 2, absolutely. But because I'm going clockwise, it's not just pi over 2, it would be what?
Negative pi over 2.
There we go, negative pi over 2. What are we going to have over on the negative x-axis?
Negative pi.
Negative pi. Up at the top, positive y-axis.
Is negative
Negative 3 pi over 2, yep. And what about when I get all the way back around and I've made one full rotation?
Negative 2 pi.
Negative 2 pi. Okay, so what quadrant, 1, 2, 3, or 4, is negative pi over 3 going to be in? Quadrant 4, yes. Right about here, going in a clockwise direction. All right, clockwise or counterclockwise on C?
Counter.
Counterclockwise. So I've got my positive angles, 0, pi over 2, pi, 3 pi over 2, and one full rotation would take me around to 2 pi. What quadrant would 4 pi over 5 be in? What quadrant would 4 pi over 5 be in? Second quadrant, yes. That's a little bit less than 1. So my terminal side is going to be right about there. 4 pi over 5. Clockwise or counterclockwise on our very last example here?
Counter.
Counterclockwise. So positive angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi. I've got my initial side right here on the positive x-axis. If I go halfway around the circle, I've gone pi rotations. If I go all the way around the circle, I've gone 2 pi. What would I need to do to get it up to 3 pi?
Go halfway again.
Go halfway again. So we're going to end, and our terminal side will be over here on the negative x-axis, and that would be 3 pi radians of rotation. Beautiful, beautiful, beautiful. All right, we're going to practice a little converting between degrees and radians. So I'm going to put another couple examples up. And before we actually get into doing these conversions, I want to remind ourselves, okay, so over here was 0 radians. How many radians was it over here when we got all the way around to the negative x-axis? Pi radians. When I'm talking about it in degrees, my initial side was 0 degrees. How many degrees was the negative x-axis?
90.
All the way around to the negative x?
180.
There we go. 180 degrees. And so what we have is that pi radians is equal to 180 degrees. I can use this as a ratio or as a proportion to convert between these units. Since I'm describing the same amount of rotation, I'm just using 2 different ways of measuring it. I can write this as pi over 180 degrees. And that fraction would simplify to just be 1 because that's describing the same amount of rotation. Or I could write this as 180 degrees over pi, because again, that fraction is just going to simplify to be 1. Now, when I'm using these proportions to do conversions, I want my degrees to cancel out. So when I multiply fractions together, I would take 50 degrees. I'm going to multiply it by one of these proportions. I take anything and put it over 1 so that I can multiply numerator to numerator and denominator to denominator. Which one of those 2 proportions would I want to use to multiply so that my degrees will cancel? Do I want to use the pi over 180? Do I want to use the 180 over pi? Which one of those could I use to make the degrees cancel? Pi over 180, yes. I'm going to multiply this by pi over 180 degrees, because when I multiply numerator to numerator, I would have 50 degrees times pi over 180 degrees. I've got degrees in my numerator and degrees in my denominator, and so those are going to cancel out. And now all I need to do is reduce the 50 over 180. What do you notice will go into both 50 and 180? Ten goes into both of them. So I'm going to reduce top and bottom by 10, and I'm going to get 5 pi over 18. Do the same thing with B. I have negative 75 degrees. I want my degrees to cancel. So which proportion will I multiply by if I want my degrees to cancel? Which proportion do I want to multiply by in order to get the degrees to cancel? Pi over 180. So I'm going to multiply top to top, bottom to bottom. So I'll have negative 75 degrees times pi in my numerator and 180 degrees in my denominator. Degrees on top, degrees on bottom. That's going to reduce. That's going to cancel out. And how will this fraction reduce? Five pi over 12. Yes. All right, last one that we're doing for today. 215 degrees. What are we going to multiply by to convert it? Oh, sorry, negative. Thank you for catching that. Negative 5 pi over 12. I want to take 215 and multiply it by what so that I can convert it into radians. Pi over 180. I always want the unit that I'm trying to get to cancel on the bottom. The unit that I want to cancel is going to go on the bottom. Degrees and degrees cancels. I only know of one thing that's going to go into both 215 and 180. What do you know of that'll go into both of those? Five is going to go into both. 215 divided by 5, I get 43 pi in my numerator. What is 180 divided by 5? $36. So 43 pi over 36. Fantastic. All right, guys. Hopefully you have gotten your introduction video completed and uploaded. If you have any difficulties with that, please let me know. If you haven't done that yet, get it to me today. You can go ahead and get started on the 6-1 homework. We're not quite all the way done with 6-1. We're going to finish it up tomorrow. And then the 6-1 homework will be due tomorrow night. So we'll get through everything that you need before that homework is due tomorrow night. Please let me know if you guys need anything at all. You can reach me through Canvas. You can send me an email message. I hope you guys have a fantastic rest of your day. Bye, guys.